Hello, everyone. This is a series about generative AI and how to utilize your enterprise knowledge corpus with current technologies. And on previous episode, I was talking about my personal experience where I have to work on self-assessment, internal audit processes, on RFP proposal development, on proposal development, and this process is more like manual search and writing text, creating different artifacts. Not efficient, takes time, a lot of resources, and quality is not so good. And often, when you need to develop proposal or even RFP, you need time is time wins deals. So you cannot spend a lot of time, you cannot spend a lot of resources on such processes. That is why you need to the solutions that will help you to develop such artifacts fastly in convenient way with minimum cost. And that's where we are right now. And today we will talk about how to build the solution. So this solution includes, just as a recap, even if you didn't see first part, just pause this video and take a look video, previous episode. But just for a recap, we have several components. It's knowledge sources where we store the company documentation in the way where we can do similarity search, semantic search, and get a context of to answer a particular question. And we use large language models. It can be commercial, it can be open source, and the applications that join everything together. And also as a recap about how to build knowledge source in your organization, you have different SaaS platforms where companies usually store their data. It is GitHub, Confluence, SharePoint, etc. It's a lot of different SaaS platforms that source for these purposes. And we have a large language model for embedding. This model creates a vector that allow us to find relevant information for our request. And we store this vector and the document as a chunks in our vector store. So in our solution, we use Chroma. It is open source solution, lightweight, and it's easy to deploy and use locally. Uh, there are many other solutions that can be used as commercial as well as in the cloud, like Kendra and Amazon Aurora with a Postgres vector extension. And let's move further to actual today's topic. In order to build this solution, first of all, you need a large language model for text generation. And here you can use different services. Um, for example, it can be cloud provided services like Amazon Titan. It is a large language model provided by Amazon. It can be Amazon Bedrock, where you can use such large language models through Amazon platform. You can use OpenAI GPT models. You can use Anthropic Claude models, Cohere, and other, uh, I would say, hundreds different large language models that are open source and they're available on Hugging Face. So with large language model, I think it's more like a clear. Let's move forward. And on the left side, you can see different vector stores. It's what we previously built on previous episode. In our case, it is Chroma. And in the center of the diagram, you can see large language model frameworks. These frameworks actually allow us to join all together. These frameworks works with large language models and allow to build application, scalable application in convenient way. So you don't need to write everything from scratch every time. You can reuse libraries and different functions, and I will show you some of them today. And in our case, we use LangChain, and but there are several others frameworks. It is Llama Index, it is a semantic kernel from Microsoft, and it is Haystack. All of them are open source, and you can use them for any purposes for commercial and other development. Let's move forward. And in order to start with, first of all, we need to do initial setup, import several libraries, and pre-install some environment variables. I use LangChain tracing. It's quite new tool, and I will show you the interface on the next episode, I think. This allows us to trace different requests to models, how many tokens was generated, was the input, was the output. So it's really good tool for visibility. And we have functions that get uh, secret keys from parameter store. That is why we use Boto3 and send requests to AWS parameter store, where we in secure way store all the keys. And we get OpenAI key from there and LangChain API key. So we set them as environment variables so that next request will be signed with these keys. And yeah, we selected large language model, selected directory. We use embedding OpenAI embedding. It's the default model, and it is our ChromaDB vector store database that we created on previous episode. Just a moment. And you should have this folder docs chroma, and in this folder we have different artifacts that are stored, so that we will use. So let's initiate it. So that is initial setup for us. Okay, that is done. And we can move forward to our execution. And let's create retrieval, question and Q&A. And let me just explain how it works. So first of all, we create a large language model with our selected model, and with temperature 0. And 0 means that model will be predictable and return only the context that it gets. So it will not, I mean, imagine, or at least it will do less imagination and will do more like deterministic to answer the question. Then we create Q&A chain. The chain we will use to send queries. And we use this large language model. And in previous episode, we fetched several results from vector database. And here I propose to use maximum magneto relevance. And let me explain what it means. So we retrieve 7 results from the vector database. And then we find 5 the most different results from these 7 and use them as a context in our large language models. And let me explain why it is better than just sending 7 documents. Let's imagine that we have several documents that are very similar, and sending very similar documents or even identical documents to as a context to our large language model will produce even worse results. That is why we need to find relevant information, but this information should be distinguished from each other. So maybe from different perspective, etc. That is why it improved how large language model works. Also, we can select different chain types. We use staff model where we just send all the documents as a one request. It is the fastest, but it is the less the producer worse quality, and the best quality produce a refined model, but it sends requests in sequence, and every time it refines the answer with new context. That is why it takes much more time. And if it is not real time, of course, refine will work better for you, but it may cost a bit more. And there's some other chain types like MapReduce, etc. And we return source documents that you can review and understand where the large language model takes these results. Okay, and moving forward, so we talk about that the solution do some internal audit or some, by, because of maybe it is requirements from your new customer, and you need to answer a particular question. And this list provides different categories like access control, data security, subcontractors, intellectual property, confidentiality, etc. A lot of different categories. Maybe not a lot, but a few of them we have. And for we we have questions in these categories about different things, about access policies, about company security store, etc. So this question we store as a data frame, and let me run this. And then we will use this data frame. So you can see that it is a loop where we get index and actual data from this data frame. And then we send all questions to this Q&A chain and get results. And we store answers. So we create the answer and store the results there. And we also can store document source document, but it just adds a lot more information, and I'm not really focusing today on this. So, but in your case, you can also it's allow you to analyze what the source documents is used, etc. So the request is taking about 50 seconds. And while you're waiting, okay, that is done. Awesome. And next step, it is we would like to score our results. So in some cases, large language model just, we don't have relevant information in our vector store. That is why we will get some kind of answer that I don't know, or the information is not relevant, etc. Something that the solution cannot answer with the context that they have. And that means that you need to find and add these documents to the vector store so that in next iteration you can get these answers. But in our case, we have score requirements, and we ask large language models to score uh, answers based on the question. And for example, 0 if show no evidence that the requirement is met, and 10 to 10 it is answer is provided strong evidence that requirements is comprehensively and consistently met. So and something in the between. And we put here a question and put here answer, and actually ask it to get a score. Let's run this command. That will be faster. It still might take some maybe half a minute. And after that, we will extract this to Excel document. And also, while we're waiting, I can show you from my previous execution. So you can see category, question, answer, and the score. And you can see, for example, first one is a 0. And if you take a look, the access policy at Mate Tech company for repositories, tasks, etc., not explicitly mentioned. So there is no information in our handbook about this that we store in vector database, and that is why we cannot find this answer. And the score is 0. That is kind of like clear why. And the next one is a similar thing. The given context doesn't provide specific information. That is 0. And we have 8. Um, Quite big answer. And we might take a look later on this. And also several 0. Then, for example, confidentiality, it is 9. Very high score. Yes, the company agrees on hold customer confidential information and etc. NDA agreement and so on. So there are some procedures for this. I don't know. This usually much more faster. That maybe evening and a lot of pressure on OpenAI. So that is why some more private large language model can be a better solution. As we talk about today, this Hugging Face open source or large language models, or for example, Amazon Bedrock or Microsoft OpenAI in private way can be more stable. But here, yeah, you can see that it's 3 minutes. Not really sure why. But I think we can move forward, and I will show you the report itself that I already stored. Yeah, you can see this quite comprehensive answer. And the question is about what is the processes of the company this for returning or destroying customers' confidential information. And here you can see step by step what company is implementing, and my expectation is that this information is fully from the context, because we put 0 temperature and we expect everything from this context. And if I mean, for example, if model doesn't know, it just doesn't. Its answer I don't know. So that's how the report looks like. And I would say it's almost ready RFP proposal, if you wish. And for example, if you see this missing information, you just find it, then ingest to vector store and repeat the process again, and you will get much better results based on this course. So thank you very much. And in next episode, we will talk about how uh, monitor and test our solution. So we will see different requests, how they executed, what these parameters, and how you can test your solution and improve through the time. Thank you.